wasn't signing. Okay. It's January 14th, 2020. All right. We are solving right triangles today. Using a triangle and our trig functions to help us find some information. Application problems, if you will. This is where I think trig is really, really useful. And in fact, a friend of mine sent me an email about we're counting Saguaros right now, taking the every decade a consensus of the health of our saguaro population here in the desert. And so there's groups of people that are going out and actually like counting all the saguaros, but not only counting, but measuring how tall they are so that we have data on their health and population, which is interesting because they use trig. And this is sort of how they would do that. And I wanted to have this dream of going around the campus and measuring stuff with inclinometers. They measure your angle of elevation. So we're going to talk about it. Okay, sorry, I'm all excited. Okay. What is the sign according to angle B? 6/10, opposite over hypotenuse. Oh, whoops, that's supposed to be 10. Very good, 6/10, opposite over hypotenuse, looking from angle B, good, and that reduces, of course, to 3/5. What's the cosine according to angle B? So what was it, 4/10? 4/5, right. Because what is this side length? 8, yeah, you have to get that using the Pythagorean theorem. So what squared plus 6 squared equals 10 squared, and it will ultimately come out to be 8. And so cosine turns out to be adjacent over hypotenuse, 8/10, which reduces to 4/5. Gotcha. And then tangent according to angle B is 6/8, again, which reduces to 3/4. Great. Okay, thanks. Okay, so when we have a triangle, it's important that we realize we can write these little equations, like the tangent of according to angle B is 3/4. Because if we can set up a little equation like this, we can probably solve something too. Okay. And so we're doing a few word problems today. Example 1, solve for x. I'll give you a second to draw the picture. Remember to write example 1 and the directions. Oh, and this is a right triangle, just so you know. I just didn't want to take the time to make the little box. It's amazing how long that little tiny box takes. All right. So we have a little bit of information in this triangle. Very nice here. We have a 60-degree angle. And if I know this 60-degree angle, what would I call this side? The opposite side, all right? And what would this side be? The adjacent side. And if I have the opposite and adjacent side, then which trig function can I set up? Tangent, yeah. Because we know that tangent of some angle, and in this case we have a 60-degree angle, tangent of some angle is opposite over adjacent, or 32 inches over x inches. And look look at, we just created an equation we can actually solve, and our calculators are going to be really helpful today. How do you suppose that you solve this? What do you want to do? Cross multiply. Yeah, cross multiply. We're actually going to multiply the x to the other side. That's going to give me x times the tangent of 60 degrees equals 32. And then how do you get x by itself? Divide the tangent of 60 away. So we're going to divide by the tangent of 60 degrees. And we get x equals whatever this is, which we can plug directly into our calculator. What mode should our calculator be in? Degree mode. Why? Because there's a degree symbol there. So I'm going to go to mode and make sure that I'm in degree mode. So make sure you're in degree mode. And then I can type in 32 divided by tangent of 60. Just like that. And hit enter. And I get 18.48, maybe 18.48. And this is going to be in length inches. Can you dig it? There's a song that uses that phrase. I think it's an old song. Okay, questions on that one? It's really easy, right? All right, last one. Easy day today, yay. Example 2, from a lighthouse deck 80 feet above the water. From a lighthouse deck 80 feet above the water. A capsized boat is observed at an angle of depression. An angle of depression of 5 degrees. How far is the boat from the base of the lighthouse? How far is the boat from the base of the lighthouse? So, when you're teaching at the U of A, I had a student who, we had a problem. It's the problem every trig student gets, which is that a ladder is leaning up against the house. It's a 10-foot ladder leaning up against the side of a house. What's its angle with the ground? Or how far is it from the base? Yeah, how far is the base of the ladder from the garage or the side of the house? And this kid, he got it wrong. And he got it wrong because he didn't draw a picture and didn't label his picture properly and didn't properly understand what the question was asking. And he's like, but I gave it to you. I was like, no, you didn't answer the question that was asked. He's like, no, I solved it right. I'm like, no, you didn't understand what was going on because you know why? You didn't draw a picture. So rule here, draw a picture. So if we have a lighthouse, then we must have water. So here's our water. And there's a lighthouse on the shore. Tall lighthouse. Oh, that was a bad lighthouse. I didn't mean to draw that way. A lighthouse. And then there's this deck thing on the lighthouse. Looks like a top hat. And that's where the light is, right? Okay, there it is. All right, so there's my top hat lighthouse. And we're on the deck, which is 80 feet above the water. 80 feet above the water. A capsized boat. So there's a boat out here in the water. There it is. There's our boat out in the water. And it's capsized. So there's this guy and he's like, okay. There it is. Okay. Okay, so he's capsized and there's like water like shooting out. Okay. Sorry. Okay. There was evidently a cannon attack. Okay. So here's what we want to understand. What is an angle of depression? So we have two angles that we really want to make sure we understand. One is an angle of depression and the other is called an angle of elevation. And so this person in the boat is being observed from the lighthouse keeper. So our lighthouse keeper is in the lighthouse and he sees this boat. Well, when people are walking around and not looking at their phones, when we're walking, our eyes are straight ahead, right? Okay. So it's natural that we always look at eye level. All right. So an eye level would be horizontal, basically. So that was a really not straight line, so I erased it. So when we're looking, we have a natural eye level, which is always horizontal to the ground, or in this case, horizontal to the water. But it's important that we're always looking straight ahead. Now, to have an angle of depression of 5 degrees means he had to lower his eye level 5 degrees to see the boat, okay? So he had to tilt down his eyes 5 degrees below horizontal in order to see the boat and the dude screaming on the boat, okay? So an angle of depression is how much your eyes have to go down from horizontal. That's really the key. Angles of depression are always from horizontal. I cannot spell this morning. Horizontal, Horizontal. All right. So if we have like angle of elevation, if somebody has an angle of elevation, he has a normal eyesight that is totally horizontal. An angle of elevation would be elevating his eyes, maybe 20 degrees upwards. And so this would be angle of elevation. All right. So anytime you have angle of depression or angle of elevation, it's always from horizontal. Got it? Okay. All right. So now this is kind of an interesting question. We want to know how far is the boat from the base of the lighthouse. We actually want to know what is this distance, which I'm going to call X. Do you see a right triangle? Yeah, just about anyway. So I see a right angle here. Our lighthouse is hopefully perpendicular to the water, standing on the land there. And you can imagine that this triangle sort of continues and, we're approximating here. Anyway, so there you go. We have a sort of quasi-triangle. Okay. How do we figure out X? What do you know? We got this height of 80 feet. That's good. We have an angle. We have a question we're trying to solve. So, do you know this angle? What's that? How'd you get 85? Oh, yeah, because this must also be 90 degrees in total from our perpendicular to our horizontal here. That must be 90 degrees. And if we subtract 5, that means the complement is 85. Hey, I just want to point this out, but there we go. We have an angle inside our triangle, so we can definitely set up a trig ratio here. If this angle is 85, what is this angle right here? 5. Huh. Look at that. That angle's 5 degrees and that angle's 5 degrees. Does anyone know why? Hey, very good. Alternate interior angles. Oh my God. Yay, you're like the first student in 6 years to know that. Wow, okay. Alternate interior angles. Parallel lines, geometry. If you have two parallel lines cut by a transversal, the alternate interior angles, these two angles, you'll notice they form this sort of Z shape, are congruent. They are the same size. So here and there's, yes, alternate exterior angles, yes, corresponding angles, all these congruent angles. Anytime you have parallel lines, this is a huge concept that students just totally forget about. Parallel lines are used all the time. Our parallel lines are our horizontal line of sight and our hopefully horizontal water, okay? It's not a tidal wave, no tsunamis coming through here. Really important that we remember those sorts of parallel line scenarios. They come up a lot in this class, especially. But we have this 85-degree angle, and if we know this 85-degree angle, what label can we give X over here? Opposite. And then what would the 80 feet be? Adjacent. Okay. And so if I have opposite and adjacent, which trig function can I set up? Which one? Tangent again. Yeah. So tangent of my 85-degree angle is opposite over adjacent. X over 80. It's just a coincidence that they all happen to be tangent functions today in notes, but we could set up sine function or cosine function based on which labels we have. Okay. How do you solve for X? Multiply by 80. So we're going to multiply by 80. Cross multiply by 80. And then in my calculator, I just like to do 80 times the tangent of 85. You'll notice you're not going to do like 85 times 80. That doesn't work. The tangent function comes first. So 80 times the tangent of 85. And I get 914.4 units. Feet. Yes. Okay. We're 80 feet above the water, so that's 914.4 feet away. All right. Good vocabulary, good geometry going on here. That's just, I used to teach, my first year teaching, I taught an honors geometry trig class. So it was geometry and then trig in the same year. It was so good because really, like, everything we do in geometry, we do again in trig. It's great. But I don't get to write curriculum. All right, there you go. Any